I think that I will start with demonstrating how the analyzing surface looks like when you read 24 hours record from a Holter device. So I will use a demo record that you can also find on the CD that you get when you purchase a system from us. So after this webinar, you can also check this record by yourself. Okay, I just double-clicked on the name of the patient in the database, and it now opens the last record belonging to the patient. Okay, so this is how new recording looks like when you read the record after 24 hours. You can see the HR values, the respiration values. You can see the trends like QT, QTC, QRS width, PQ distance, and so on. And also you can see the ST level or ST slope for the channels separately. This is a free channel recording, by the way. And okay, we have many functions that you can use for analysis. I would like to show you just a few of it. The most important functions, like how you can clear noise out from the recording, how you can make the beats, sort the beats in different templates, and how you can easily rename beat to another beat type, like from a ventricular to a normal beat, or to a normal beat to a supraventricular, etc. So let's see. I would also like to talk about a bit how you can practically organize the workflow of analyzing a recording, like what to start with and what's the second option that is good to do. And we have a function for that. So on the top of the window you can see a toolbar where you can see that you can go back to the database, or you can print the results, you can manage your settings, or even get help from the user manuals. And there is an option that I talked about, this sequence of tasks. If you open it, you can see a list here. It will show you a default template that you can follow, like clearing the QRS templates, finding the error intervals, the RR max and minimum, and checking the atrial fibrillation, the ventricular events, supraventricular events, finding the min-max HR and QT, and so on. And in this window you can also see who was the physician and when the modification was made. So let's say I've done the QRS templates, I just tick it, and it will store a date when it was ticked. And now the physician's name is XXX and XXY, but yeah, it will be the physician's name right here. Okay, it just makes your workflow a bit easier, but you don't have to exactly follow it. It's just a little help. As a first step, I would like to talk a bit about clearing the QRS templates, which I can do on this tab at the top. Okay, so now you will see all of the templates that was made by the automatic analysis. It ordered all of the beats in different clusters, and as you can see, all of the bundle branch block beats are stored in one cluster, and you can also see different clusters as well, because these clusters are made by the shape of the beats. So let's say you have an exact shape, and you can see, if you contrast a bit, that most of the ventricular beats in this cluster has the same shape, and they are all stored in this template. But if you feel that like this shape is out of this should be out of this cluster, you can easily cut it out manually, and if you click on yes, it will demix this cluster and create a new one for these beats, like this one. This is the all of the beats that I've cut it out from the previous one. Okay, so all clusters have an indicator that you can see if the green, it is fully green, it is a clear cluster. But if you can see that this circle has a red part, it means that the cluster is a bit mixed. So maybe you have to work with it a bit. Like if you can see this channel 2, it's a bit mixed. So let's try to clear it out a bit. I would like to cut this out, and also this one. And okay, so let's say you want to demix this cluster. You can do it manually, or you can do it with auto demix separately by channels. So let's say I would like to demix the first channel, and then demix the third channel. As you can see, it's already a bit more clearer, but it's not perfect. You can also say this channel is too noisy, or this channel is too noisy, and these beats cannot be ordered in any type of beats. Then you can just rename a whole cluster by right-clicking on its surface, and let's say now it contains 19 beats, and let's say they are all noise, even if they are not. Let's say I would like to mark them as noise. I can change the beat type to noise. Now a new noise cluster has been created with all these 19 beats. So if you mark a beat as noise, it will be excluded from the statistics and from the calculation of other parameters. Okay, these are the basics of clearing the QRS templates. So it is way more easier than scrolling through all of the beats and renaming them one by one. But you can also use this waterfall function here. Waterfall shows short sections under each other, where you can easily see that the middle one is the selected beat, and you can see easily if you scroll through this function, I mean all of the ECGs stored in this cluster, you will see if one beats are a bit different like the others, like this one or this one, and you can just select them, rename them, but you can also select multiple ones by holding the control button and just clicking on these beats. Or you can also select them with the shift button, so you can select multiple beats at once. Okay, I think it's a useful function, but let's move on to the next step. I think the next step is finding the error interval, which is the distance between the error wave of two complexes. Like if I go into the main window, so if I select an interval, it will show that the error interval is now 891 milliseconds. Usually this is the part of the analyzing that you want to find the minimum and maximum of these error intervals. There are multiple ways you can do it in CardioSpy. I would like to just show you at least two of them. Let's say I would like to go into the events, where you can also see all of these type of events like ventricular couples, like runs, tachycardias, and the same for supraventricular beats, and also RR and HR, and also atrial flutter or fibrillation, but I will talk about fibrillation a bit later. So let's say we are here in this events menu. You can also find in this events tab the RR min. I can see that it's a bit noisy, so I'm sure that it won't be a valid error minimum. I can even do it by clicking this event by this X button here, so it will go to the next one. As you can see now, there are 79,000 beats, and if you select this error min event, it will be ordered in an ascending order, so the shortest error interval will be the first. So you can just scroll through all of these beats and find the minimum. So okay, let's say this will be the error minimum. I can click on this fix button. The button says press X to fix error min or max. Since now the error min is selected, you can use this fix button to make this interval as error min. And now it will be the first one. And it's the same with RR max. Now we have a huge pause here, so I won't edit it, but it works similarly, but in a descending order. You can also do this in another menu. It is also a good function. You can find it in the HRV tab. So as you can see on this graph, it represents the graph of the RR intervals, and the RR intervals are ordered in short ranges, like from 560 to 569 milliseconds. And let's say these intervals are invalid, so I can just hold the shift button and move the cursor by clicking the left button, and then I can delete the selected range, and now it will modify the RR min. But you can also select another range and scroll through all of the beats that are in this range. And you can fix the minimum error interval or the maximum with these buttons. The best thing with this graph that you can also undo your editing by make the invalid intervals valid again using the same method. So you can also fix previously deleted intervals. Okay, I think there is even more way to do this, but these two are the most easiest one. Let's move on, detecting atrial fibrillation and flutter. Of course, you can see flutter on the ECG by just eye, but there is a more easier ways to do that. One thing I would like to show you before I move on is that we have median, that is SA-ECG, where you can see where the P wave begins and ends, where the Q wave and where the T wave. So you can also see that if the P wave is missing from the ECG, like if the patient has a flutter where the P wave cannot be detected because there are multiple waves that could be detected as P wave, you won't see this marker, like the P wave is missing now. There is a function where you can detect atrial fibrillation in a more easier way. You can find it in the main tab and in the AFAV submenu. But I think there is a better recording to do that. I would like to open it instead. I won't save these changes that I made on this record. Okay, so let's say I would like to open the same function, and we have, in CardioSpy we have a function that is called bird view. That is basically really a bird view of QRS complexes. I can explain it further if you want. I would like to show you a picture. So as you could see, this picture shows the same function and even the same record. You can see that the error interval is chaotic, so it's changing very frequently. And also you can see that the P wave is missing from the ECG, which could mean that the patient has atrial fibrillation. It is a very easy way just to see these two graphs about detecting atrial fibrillation. You can also check all of the ventricular and supraventricular beats. At the first part of the analyzing you have cleared the QRS templates, so there should not be too much noise on these beats, but it is recommended to scroll through, like checking the V couples. You can do it easily by selecting this ventricular ectopy and V couples. So you can just check every, like this one. Since I have not cleared this QRS templates yet, there should be noises. So let's say this was falsely detected as a ventricular couple due to noise. So let's say I would like to just mark these beats as noise instead. And this reduces the number of events already. Yeah, like now it's 19. But you can also check all of these events like ST-min or max, and like longest tachycardia, ventricular tachycardia, or longest supraventricular tachycardia, and so on. Okay, similarly, like in case of RR interval, you can do the same with HR, like finding the average HR minimum. You can use this function to do that. So let's say this isn't actually the minimum HR, so I would like to delete this event. Okay, we have many more functions, like marking noise in a full ECG view. It is also not that difficult. You just have to go in a section, scroll through here and find the noisy parts, like let's say this is a noisy part. I would like to exclude this part from the calculation. I just want to hold the shift button and the left click on the mouse and say that this should be excluded from the diagnosis. Now it is marked with green. Also, we have a summary in different formats. Like you can see that the patient information, ST parameters separately by channels, and a short description of the results, and all of these events separated by hour. And you can also see the total values and how much percentage they are in the total. We have also a very important function which is called sleep apnea. I would like to open again another record where you can actually see a sleep apnea event. If I know correctly that atrial fibrillation has something to do with sleep apnea, so like if you have a patient that has an atrial fibrillation, it is also recommended to check if the patient has sleep apnea. Okay, as you can see that sleep apnea events are highlighted with red. And this blue signal is the respiration signal, and this band is about the frequency of the breathing of the patient. I would just like to zoom on it a bit, and let's find the sleep apnea section. I'm not sure how much familiar you are with sleep apnea, but with this function it's very easy to detect it, because sleep apnea is the lack of breathing. Then the patient starts to breathe very frequently and very hard when he's sleeping, and it's called even sleep apnea because you can only detect this event when the patient sleeps. It is also recommended to set the awake and the sleep time perfectly for recording, because only then will these sleep apnea events will be detected. So like this one is a sleep apnea event. It can be seen clearly. I think these are the basics of the analyzing surface of CardioSpy. Now I would like to move on with importing, exporting and printing.